Hello there. Uh, Today we are going to start something about. Let me make it my screen big. PPT. Let me check it out with pen. Then I'll also check the what do you call color. We will go with this one. Okay. Today we are going to see something about best first search, which is also called a greedy method. Why it is called a greedy method? It will go on till he got the solution, and this works on informed search. What do you mean by information informed search? The information which it got. Okay. Before I move on to this topic, I request you all, those who are watching, do subscribe my channel. And we have got an algorithm available here. It works on a heuristic value. What is the information which it got information? What do you mean by that? It has from initial stage, after that where it has to go, where I repeat my sentence, where it has to go. It got the information from where? From heuristic function, from heuristic values. This is what it got. Let open be a priority queue. What do you mean by priority queue? Based on the, if you have a queue which is first in first out, okay, and stack is last in first out, LIFO, okay, and it is the data is stored based on priority, based on the values, and we will see all this algorithm as we solve the problem. But do remember, whatever the value is stored here is in the queue with the help of heuristic function. This is the major part. First we will open, we'll take a list, we'll call it as open, and if open is there is no node, then will return as a failure. Otherwise we will remove the first open and we'll take out the element, and we will generate all the successor node if it is not what you call the goal. Now we will solve the problem, and then we'll come back step by step to this algorithm, and we'll see how this algorithm also work out. Now I have got a graph which is available to me, which is available to us. We have got A, B, C, C, D, F, E, H, G, K, J, I. This is my source, this is my destination. So I have to start from A, and this is my destination. And these are all weightage which is there. Cost. And please, in best first search, we are not bothered about this cost. We are not bothered about this cost. So remember, whatever the cost is just leave this one. We also got the given data which is from A to J, which will be given to us is 40, the destination. B to G, the cost is 32, and this are all this. We will see all those things, but we have to concentrate on this one as I written given. Let's move on. I have A, which is I posted in the queue. Queue is empty, so we initialize this one. Now I've got nodes connected: A to B, B to C, C to D. I have mentioned here A I posted in a priority queue. First one I remove that one. Then I move on to A to B, B to C, A to D. This is A to D. So what is so A to D? This should be D. Sorry again. So now let's move on. A to B. A to B is this one. B to J. What is the destination I have got? 32. Correct. Okay, I mentioned here. Then A to C. C. A to C. C to goal. I have to see. C to 25. C to G is 25. I mentioned here. A to D. D to goal is 27. I mentioned here. What is this? I have got A, which is not the goal. Then I have got, which is based on that, I have got B, C, D. What is the value, heuristic value? It is 32, this is 25, and this is 20. Place, place this in a priority queue based on the heuristic values. So I've got 32, B, I've got 27, I've got C. Let's move on to this algorithm. Open. If open is empty, open is not open, node, whatever the node you have put A. Then what? Generate all the successor node and put them newly generated node open in accordance with what F values. So what we have done it, we have removed this one and we have taken B, C, D, B, B, D, C. So what is the value? Based on that heuristic value, which is now minimum, I'll take out 25. I've taken out 25. These are all there in the list. We are not bothered about this one. Leave it. They are in the queue. Priority queue. What is the priority queue? I have got the list based on their heuristic value, which is the minimum, that is 25. That is heuristic value. That is called priority queue. Okay. Now I have got from C. So remember, from C where I'm going to E, I'm going to F, I'm going to, and also I'm going to A. Do remember it. But A we have already gone. Let's see. A to C, A to C to E, E to G, what? 19 taken. Yes, it is there. C to F, F, C to F, F to goal is 17. Remember, I've taken that one. And C to A, C to A, C to, I've got C to goal. What is that C to goal? C to goal is 25. Sorry. Sorry, I've got A to G, and I've got 40, which is available to me here. So I've written, but it is already closed. So we are not bothered. We have already visited that site. So you don't have to bother about this. Leave this one. So I've got A and E and F based on this new list, based on this new list, based on this new list, which is mentioned here. Now let's move on. So I've got E, which is 19, and this is called 17, right? I've taken C. F, F to goal. What is that? F to goal, F to G, F to G. We are going to goal. It is, goal means from F to goal we have to board 0. So this is our goal, G. This is our goal. What is the path I am going? A, C, F, G. A, C, F, G. And move on to algorithm. Generate all the successor node and put them in a newly generated code. Yes, I have already done. If open is empty, it is not there. Remove the node. Yes, we have removed. If node is the goal, then return the path from initial to the node. If the last point, return the node to the last point. Here what we have done it, A, C, F, G. This is our path. So I am coming A to C, C to F, F to G. This is my call. The cost, let's move on to other one. The cost, we have got 14, 10, 24. If you calculate it, it will go into 24. Now, if I, as per this one, which I have got, A to 14, 14. And if I go to different path, whereas in best first search, in DFS, first of all, what I will do, A, B, and I'll explore this, and I'll explore this. I have to explore B, I have to explore C, I have to, from B where I'm going, E, I have to explore that one. From C where I'm going, I've already done it. From D where I'm going, I have to explore this. This is uninformed search. Whereas in informed search, I got this one. This, what I have done, 14 to 8, and this we will be using in A star. Then we are not going to use this part. So what is the cost I have got? 44, correct? And this we have taken into account, correct? This, the cost, we have to remove this. Again, I have to go to the A initial stage, which is available in the queue. Then I have to start, which is the nodes which are available to. I have got B, D, and F. I have B, D, F. Based on their heuristic values, which are given by the which are already given to us. That is A, B, B to G are posted 32, 25, 27. Then we posted this based on their heuristic value, which is minimum, which will go on the top. Then I'll remove from there. I've got C. Then from there I have to move. This is best first search, and the space complexity is omega B to the power of omega B to the power of M, or omega B to the power of D, where B is a branching factor and D is the depth of a tree. So do remember, the space complexity is B to the power of D, where B is the branching factor and D is a depth tree. Thank you very much.